Hey, this is Morgan Beauchamp, and for mini video 3, we're going to talk about chromosomal aberrations. And these are an abnormality due to a missing extra or irregular portion of DNA. There are many kinds of aberrations, but today I'm going to talk about inversions. Now, inversions occur when a region of DNA is broken, and this can happen for a multitude of reasons. However, the DNA must repair itself quickly in order to avoid damage or even cell death, and these speedy repairs can lead to new sequences of chromosomes, like the inverted one. So let's look at individual one. They have two chromosomes with regions MLI, JKHG, and GHI, JKLM. So, what occurred in this arrow right here to allow for this swap? Well, we see the regions I, the centromere, the J, and the K remain the same between the two chromosomes, so we know the inversion must have occurred there. And since the centromere is present, this is what is known as a pericentric inversion, as opposed to a paracentric inversion. And pericentric inversions have these little loops here. And these loops occur in meiosis 1 and prophase, or meiosis 1, prophase 1, due to the centromeres of the two chromosomes lining themselves up for potential crossovers. And the loop is due to the difference in location, whereas regular chromosomes will not have this. So, a quick whiteboard illustration of this. Here's a quick key to this, and we're going to see a crossover event in this example between J and K. Now, there are four potential chromatid or gamete possibilities here, as routed or as shown through the four potential routes that you can take. And that's going to give us these four gametes. So, are these gametes viable? Well, if the answer is yes to either of those questions of repeat slash lacking regions or size, then they are not viable. So regions 2 and 4 are not viable due to a repetition of either L and M or H and G. Now let's look at individual 2. They have regions MLI, JKHG, and GHKJILM. So the brain would like to remind you that if the letters are simply in reverse order, that they are actually the same chromosome. So that's the case here. We have no aberration, so let's make this easier to see. A little illustration of the crossover between J and K, and we're going to actually get chromatid possibilities that are the same as the original. So there's basically not much of a change, just DNA synthesis. So the gametes are all viable. They do not violate any of the rules. And now we need to determine who is more fit, individual 1 or individual 2. So individual 1 has a 50% gamete viability, while individual 2 is at 100% gamete viability. Thus, individual 2 is more biologically fit and will likely survive on into the future. So thanks for watching my video.